So we have Lauren Siegel from Math Happens Foundation, and she's going to conduct a workshop on making projects relate to math concepts. So, Lauren, please.
Thank you very much. I'm actually here with my colleague Kwan, who has worked for Math Happens for several years. Kwan is a student at University of Texas at Austin.
Hi.
And will be the hands that you see on the piece of paper. So we're going to be working together. I have some slides, but we're going to try to actually make some things. Wanted to keep it super simple. So it's scissors, sticky notes, paper, and oh, I think I need to do something here. Go slideshow. Hopefully you all see the presenter slide. And then I would love to have you include in the chat, you know, why this session? What about math is of interest to you as a Fab Lab, or maybe frustrating, or are you just curious? How can we do this? I would love to have some of that information so that we can try to consider where everybody's coming from. I am 100% convinced that math belongs in makerspaces, and we hope to show you some reasons why. Our foundation has been going for 9 years, and we will continue on this project at putting resources behind it and growing what we're doing. So your first project number 1 is to make a hexagon.
Sorry, Lauren, I don't know if it's only me, but I can just see a screen that reads loading, but I cannot see any slide.
Okay, so you cannot see my screen? My screen sharing, oh.
Yeah, I can see a screen with the browser, but I can just see
okay,
something that reads loading. Is Google Slides that reads loading, but I cannot see anything else.
I am trying again. If nonetheless, your job is to make a hexagon. So take your paper and your scissors and go ahead and make a hexagon. I'm going to stop share and reshare and see if we can fix this problem. Oh my gosh. Unexpected problems. It's not working.
I can see black screen. I don't know if it's only me. Or...
Oh no. Okay, well, then I guess we're going to be doing this in person. So I'm full screen to everybody. You can pretty much see me.
Yes.
We are going to start out by making a hexagon. So has everybody had just a quick chance to cut out a hexagon? I can't believe my slides. I'm going to try again in a minute, but how many of you made this or tried to make this? Right? We've all got our paper, we're trying to make something, and we've supposed to make a hexagon, so this is what you made. This is you can show it if you like, but yeah, oh, very nice. Okay, so this is what happens in mathematics. We say hexagon, this is it, and that's all there is, and the kids move on. But one thing that making can do, and making math models can do, is expand our ideas about what mathematical structures are, and we can expand them for even the youngest learners. So I have actually started out this opener with a puzzle that's made by Christopher Danielson. He is a mathematician. He works for Desmos, but he also makes math materials for the very youngest learners. We're going to try to get through some ideas for different ages. All of these are hexagons. And when we offer a way to interact with these shapes that are all hexagons, but not necessarily this one cookie cutter, we're expanding our ideas about what structures are and what we can do with them. I'm going to try to share my screen again. I see people leaving. I'm just.
Now I can see.
You can see? Okay.
If you don't press the slideshow button, it's working. So like that, it's working.
Okay, then let's do this.
Yeah.
So there we go. There's our hexagons. We tend to like shapes that tessellate, right? That's another thing that we learn in school. These three are good. And then pentagons, they don't tessellate. But what we've left out is a whole world that we can explore through making techniques. And so I'm going to have Quan show you how to tessellate. And what I would like to do, can you all see the little square, the yellow square now?
Yes, yes.
With her hands? Okay. So she is going to show you how to create a 5-sided figure that can tessellate. Let's go ahead.
All right, so here we have just about 7 or 8 sticky notes. It can be any size. Here I have, I think, 7. And then we just want to cut it in half so that we get a rectangle. It doesn't have to be perfect. And then you can put the other one aside. You can just use one side. And then you want to cut from a corner, and you want to cut it to an edge, the edge opposite from it. And you can cut it to any part of the edge, right? So start from the corner, and I'm just going to choose a random spot on the edge, and this can go. And then on the opposite side, so this is the edge we cut. On the opposite side, we're going to cut 2 sides, right? Because we're trying to make a 5-sided figure. So we have 1, 2, 3. So now we're going to do 2 more, and we're going to start anywhere on the edge. So I'm just going to pick this spot, and I'm going to cut it to the edge on the side. Again, you can just pick any spot. And then one more time, you're going to start from the same spot. So this same spot, and you want to cut it. And again, you can pick any of the spot on the side.
Can you see that, Ivan? I saw one note somebody couldn't see.
Yes, I can see, but I need to pin. So please, to the rest of participants, if you open the participant list, you have two different, from Lauren, you have 2 different cameras. So pick in the second one, and you can see the camera.
Yeah, pin the 3 bubbles. Okay.
All right, so now if you finish cutting, you're going to have a 5-sided figure. You have 1, 2, 3, 4, 5, like this. And then what we want to do is we want to separate them, right? Because we cut them in a stack. So now we have 7 or 8 or however many you stack them on, identical figures. And so now what you should be able to do is you should be able to fit them together. You should be able to tessellate them. And you should be able to do that by rotating and fitting them together. So let's go ahead and you can try it on your own. I'll just use mine.
Oh, it's sideways too. Boy. That's okay. Keep going.
Okay. Yeah, and you can put it in any orientation. And you can make a picture, or you can make it in any shape you want, but you should be able to tessellate it.
Perhaps when you are showing, when you are showing the video, it would be great if you could stop sharing screen, so we can have also the image in the recording later.
Oh, okay. Let's see.
Yeah.
Is that better?
Thank you.
Okay, sorry. So everybody, if you went ahead and did the cuts that way, should have different 5-sided figures. Yours are all different, but they will all tessellate.
Yeah.
And from here, where everybody's created their own thing, we can identify the angles and show why this works. This is something that anybody can do. It's kind of like a magic trick where you magically create these 5-sided figures that can tessellate, but you can parlay that into a discussion of the mathematics of these shapes and how they work. Tessellating pentagons is part of a 100-year story in mathematics, and it has a reach far up into university level math, but it's also accessible for, you know, even a 3rd grader. What I want to show you now is that, first of all, there's a link to a video in the slides that you can go to and see exactly how to do this. What do we do to really communicate all the tessellating pentagons? This is a museum in Paris, and it's a digital display. This is the opposite of what we want and what we need in mathematics. Here's our display. We cut these out of wood. This display has all 15 kinds of tessellating pentagons. The one that you created was number 1. And once they're created, we can actually make designs that help teach the structures of these things. So it's 100% mathematical, but also creative and also leveraging what maker spaces can do. And it's shareable and discussable with other people. So making matters in mathematics. There's a long tradition of mathematical makers. And when we make puzzles and we add our own ideas and creativity to them, that's when the learning sticks. We talk about there being a path to getting better at math, but the paths aren't working and we don't have enough. And what we really need is the help of maker mindsets and actually the things that we can make in the labs. We're going to make one more thing in a moment, but I want to share this slide with you. This is a paper pencil activity, and it was a series for high school students. There they are doing something paper pencil, and here they are exploring models. Both sessions looking at very similar math concepts for high school students. And you can see going back and forth the difference in the body language and the engagement level. This is what convinced us to put our foundation resources into making math and into making math a part of Maker Ed. I've got one more project for you. It's a very simple one. And so I'll stop share and Kwan is going to get a triangle out. So if you can re-spotlight, and we'll show you something that you can do with the triangle to, do you want me to turn this?
Yeah.
Okay, we're going to turn this, hopefully looks better. That looks better.
Yeah.
Okay, so this is middle school skill concept, and all you need is a triangle.
And it can be any size.
Any size or shape triangle. And we're going to start with the pointy top and fold it down. So that the line across is totally parallel. Okay, and 2 more folds. We're going to make an envelope out of our paper. It's a little bit hard
I
to
don't
see.
think, yeah.
It's
Might as
gonna
well.
work. Oh, no. Something happened. She's gonna adjust. One of the things in mathematics is when something doesn't work, you get a red mark on your paper and no feedback. When something doesn't work in a maker setting, the parts don't line up and it doesn't show what you want it to show. So
So there's actually one way that I found this when I was doing it, which is, I guess, a maker way of like thinking. Instead of doing that, I found that this is also a way to do it.
that's for 90-degree angles.
Yeah, so you get you get the bisecting lines of you get the midpoint of this side and you get the midpoint of this side.
Oh, okay.
And then you
To
line
make
them
it
up.
work.
And then you line them up.
Okay.
And you line them up. Like that.
There is one more thing going on here that I want to emphasize. Math teachers make with paper all the time. And things like this happen all the time. The digital technologies that you work with have created an opportunity to make models that work perfectly. And that is something that we shouldn't just ignore or lose in terms of an opportunity for teaching. Do you want to show the wooden one?
Yes.
Crazy things are happening to you. Okay, try this one. This thing's kind of big. This is a great big triangle. You'll see, and it's been cut across the middle, the midpoint. Oh no. And you can fold it and fold it and fold it, and you get the 3 angles fit together. It's to show that the sum of the angles of a triangle are 180 degrees. A second way to do that, and that's the other thing, when we challenge ourselves to describe mathematics and make projects that make physical representations, we can take 3 triangles and simply put the angles together. 1, 3, 1, 3, and 2. And then we can see that they always add up to 180 degrees. The key benefit to this is that a student can make their own triangle and try it out. It doesn't just work with this one kind of triangle. And that's something that we really, really have to have in mathematics. So we can fold the triangles. We can also make straight up math models. This is one that a teacher in San Diego asked us for. It's a unit circle. It's made in a makerspace here in Austin. And she wanted 6 of them. So we sent them, and she sent us back these photographs. These are students who were struggling with the unit circle. And because they had a model to look at, as she says, they've been figuring out the angles and the triangles and rearranging them. This is a case where a teacher wanted a specific model and we were able to provide it. But we really need more Fab Labs everywhere to engage in mathematics and engage with mathematics educators to get them the models they need to really help their students. We only have one math museum in the US, and so where else can people go for hands-on learning in math? We have a room here in Austin. We are opening a location in Houston. all of our materials are made at Fab Labs. We don't source things in a single type in hundreds of thousands. We source them in a variety of Fab Labs and maker spaces from Houston to Minnesota, California, New York, to try to make the models that really have a meaningful impact on education. The one in the middle on the top is a conic section model, and we've sent out over 5,000 of those to educators. They really want to be able to see and show what a conic section looks like and how the pieces relate to each other. And they just can't do that on a screen in the same way as if they have it in their hands. These are a couple of other models. If you look through our presentation, you'll get to this link, and there are many, many, many pictures of the different models that we have. This is animated, but I can't animate it, and it shows how you can string a parabola on a frame, and then you can use that parabola to see how a stream of water makes a parabolic arc. These are all things that we don't have in math right now. We're just sitting in our classroom, not knowing how to relate what we see on our paper or what we see on our screen to things in the world. So that is, I have one more project, but I see people dropping out and it's worrying me. And I wonder if we could unmic and have a little bit of discussion about what's helpful in this and what's not helpful. Math happens just to, I want to open it up so that we can use some of that time for discussion, but we're a private foundation and our goal is to put our resources, and I mean money, into something that helps kids learn math and helps people who have lost learning recover, and it just makes the math learning community wider. So I would love to hear from you a little bit.
Lauren, don't worry about because the people is coming and going. They're moving from different workshops. So, but is there any? You still have 10 minutes, but do we have some comments from the audience?
Questions or comments?
I just want to say thank you. I'm a big fan of yours. I have some of your stuff in my makerspace right now, and I am volunteering on Mondays to do a restorative justice math-centered after-school program at a public housing community center. And so I'm always looking for ways to do making through math. So they get a lot of hands-on tangible stuff. They do a lot of like fun math games and kinesthetic math. But I'm a big fan of tinkering and making. So this is a huge asset to my life. Thank you for sharing. And if we have time for another activity, or if you could share the slides.
Yeah, I can definitely share the slides, and we can definitely do one more quick activity. Is there any other person with question or comment? Or we could just move on and do the one more activity.
Hi, thank you for that. My only question is, I work in a Fab Lab, and most of the time, whenever I try to do more, let's say, not stuff with digital fabrication, my students will go, why? Right there, so when you were like, oh, make a hexagon, my first thought was my students would say, well, I can just make that on a computer and it's a perfect hexagon every single time, right? So can you talk about the tools that you've used to get kids excited to actually make something hands-on instead of having it all be just digital fabrication?
Yeah, so we make things that kids can interact with. Sometimes it's designing the puzzle. One thing that we've had a lot of success with is literally just a piece of cardboard with 2 holes in it. And we've used the golf tee and eraser to make those holes. And we literally just show them how to make a design like the seed of life. with just those two tools. And when they see that pattern emerging from their own, creativity, rather than just coming out of a machine, they have a sense of accomplishment that you don't see other places. But particularly in mathematics, it can be a challenge. I'm grabbing a puzzle that we just recently made. We have some things that are like optical illusions. And I wouldn't say necessarily that kids are always going to create all of math from the start, but you can teach them maker skills. You can ask them, well, you tried to make a hexagon with paper. How would you make it in a CAD? How do we get the perfect hexagon? Or how do you make some other kind of hexagon? What are the properties of this thing? How do you change the angles? How do you get this? How do you get this from the machinery and equipment that we have, if this is what you want to make? And once they have some practice of trying things and making things, then they start to get excited about doing their own, or they want to make a different version of what you've already got. This is an optical illusion. I'm just kind of excited about it. We just did it. These two things are exactly the same, but they don't look that way. And understanding that the world doesn't always show you, things are not always the way they seem, is entirely a part of this in mathematics. One of the things that kids get really excited about is a simple, it's called a Sierpinski pattern, where you draw a downward triangle in every upward triangle. This one's made digitally, but you get the idea. You make more and more and more, and you actually are working with a fractal. And kids love to start building something like this. Once they see you can build this, they want to build the next one and see it grow and grow and grow. Another thing that is super simple from a Fab Lab providing materials perspective is this thing. It's two pieces of wood with holes in it and a wing nut so you can tighten it. And we just have had some feedback from some math teachers that their kids are so excited to string this. This is a parabola, and you have to follow a process and do everything in order, and then you get the design you want. If you're making something with linkages, little bits of cardboard, then you have an ability to make a hexagon, but you can also distort it and play with it. So all of these things contribute to students' sense of spatial skills, their understanding of these geometries, their understanding of area and perimeter. This thing actually has, you can make it a square, has a certain perimeter, and you can make it a hexagon, and also I think a triangle. It's a little bit hard to hold.
Lauren, what are the connector pieces? Are they just standard brads, or are they something nicer? Okay, cool.
Just standard brads. These are just little, this is a mat board that you would use in a for a picture frame. So it's a little bit strong, but it works very well. And what I was trying to describe for you with the making designs is, I'm just going to do, what am I going to do? This. I need another pen.
I can get it.
Oh, I can just use my brad maybe.
Okay.
I'm going to try to be creative. Hope you guys can see this. Is that you can decide with your golf tee and eraser how big this thing is, right? Punch your holes. And now all of a sudden you've got a tool to do some Euclidean geometry with. If you want to make, and then you're making what you want to make. We're finding that you can,
Can I add? May I add something?
yes, Quan.
Yeah, so like, you know, I'm maybe not biased, but like when you give students something that they can touch and that they can explore, it becomes something that like it's there and they can find meaning in it. They can find meaning in it for themselves. So the triangle activity we did earlier, I was, during the keynote speak, I was just playing around with it and I just started folding and I ended up with like finding all sorts of shapes and trying all sorts of making discovery, and that becomes like a project that I like enjoy, and that like students may not be compelled to make these seemingly trivial discovery on like a CAD software. And I think this is an important
Yeah,
learning.
I mean, the best analogy for me is when they're on the computer and just getting that linear pathway to success in math that we're so focused on. They're not trying out this, and they're not making other things, and they don't have an open-ended question to solve. And that's too bad, and something that we want to try to help provide other ways of learning and other ways of knowing. So I made something simple, but you can keep going from there. You can do all of Euclidean geometry with a little piece of cardboard. And then you're not struggling with a compass. Struggling with a compass is a real problem. Those tessellating pentagons. This is pentagon number 9, got made into an amazing puzzle. All of these pieces are exactly the same as each other, and yet it looks like an extreme variety. All of our designs and ideas, we have make and takes, we have models that we've created, we have things. This is an icosahedron. You need golden rectangles to put together to make this. And the Maker project can range from, here are the proportions of a golden rectangle, figure out how to make this, to just, here are the parts, put it together. Or what can you do with a color scheme on the various sides to show us more about the structure inside. Curve stitching is a really good one. If you can provide frames from your Fab Lab, then students can create all kinds of designs. And for college students, they may take an interest in this. This is actually just string strung. This is string strung, and a design so that you can make a hyperbola. This is the kind of model that you see in an old museum that we can have again today and use to engage with more learners than just those that learn from computers. Creating these in a Fab Lab, learning how to put them together, understanding that these are straight lines that create curves is incredibly valuable in mathematics. And so many things in the keynote were relevant for us, just in terms of, let's not just fill in the bubble. mathematics is a lot of filling in the bubbles, and let's make ideas real. So let's take these math ideas and make them real. The other projects that I don't have time for, because I think we're out of time. If you cut 2 squares.
Lauren, we have time, so we
Oh,
have still
okay.
more than 10 minutes. Okay,
Oh,
because it
okay.
was until sharp.
Okay, so other project, if you cut 2 square, if you have 2 squares, area 1, and you cut them both across the diagonal, then you can put those parts together and you can get, you don't have to, I'm just going to do this. You can get an object with area 2, a bigger square. And what is the side length of that square? It's an irrational number. The square root of 2. It goes on forever. Irrational numbers are hard to wrap our minds around, that this digits can go on forever, and yet somehow it's bigger than 1 and less than 2. And what is it really? We can just make a model of it. Take these 2 pieces and put them together. We've got an area of 2. The bonus project is also a really good one. It's called the Spiral of Theodorus. And this one, we actually manufacture all the square roots of all the numbers, could go on to infinity. I hope you can see this. There are links to Kit and how we do this with people. Teachers love to do this. Kids love to do this. First, you start with a square and you cut it along the diagonal, and then you build the next one and the next one and the next one. Each time we get the new square root. If we were to take square root of 4, we could compare it to our 1 and see that it's exactly length 2. This is a concept in mathematics that also is just fun to make. And then we've seen creative designs based on these: baby carriages, shells, Princess Leia's hair, if you know Star Wars. Once you have this, you can think about the fact that you have diameters or radii, that are square roots. And you can actually make concentric circles, pi r squared. This middle one, radius 1, would have area 1. This one will have area 2, area 3, area 4. So each additional ring has area pi. This is something you can make if you can make a spiral of Theodorus and go on from there. These are the same kind of skills that you're using in your Fab Labs. Make a tool and then make something with that tool. These are direct analogies to what we want to be able to do in math. So these were the other 2 projects that I had in here. You can actually fold a spiral of Theodorus with paper folding, and that is fun too. I think that there's a link to that. The video should be the paper folding. And so I hope that you will watch that. And if you go to our catalog and you see anything that's of interest, from, you know, this straight up model, this is a model that that can really help make math concrete and show that it does relate to the real world, we are more than happy to share with you. We try really hard to make all of our files in formats that other people can use. And we do fund projects too. If there are teachers that want models in your area and you want to provide them, we can help fund that kind of project. So I really appreciate the opportunity to talk with you, and just to let you know that we are looking for maker spaces that want to do math and looking for projects that we can help support with stuff or sometimes money. Can't just, it's a long story, but we can definitely send stuff. Sometimes we can send money. We do workshops in Houston, Texas now, Austin, Texas, and hope to do some in Albuquerque for teachers. Any other questions or anything else I can address? I'm going to share a link to this presentation right now.
We still have time for at least one or two
Oh,
questions.
okay. I'm
So if-
confused about how much time I have. More
Yeah.
questions? More questions, or I can try to show more stuff.
I have one question. So this is very practical approach, so the kids can see the math, right? But what is your recommendation? I mean, because in the end they need to learn also about the abstraction. So it's first explain the theory, what is an irrational number, what is the square root, and then show how they can build it, or the other way around. You show them first how they can build this spiral, and then you explain them the math behind. What do you think is the best approach, especially for primary school kids?
Yeah, so we work mostly in the public space. We try to help teachers have math field trips. So we have a lot of collaboration with museums and cultural centers. And when we do things for the public, it's for families and it's kind of all ages. So a younger kid that sees all this, they might just want to take it apart and put it back together so that it goes back together and looks like it did before. A student that's studied this, might know specific things about what is a circle and the equation of a circle. We have a Trammel that's a gadget that makes an ellipse, and you can actually get to the equation of an ellipse. So I like both. I think if a student has had a chance to, or a kid, let's say a kid has built this, they don't know what it is, they don't know what a fractal is, but later in their math career, they're now trying to figure out what part of this is going to be the green, right? The cutout pointing down. And now they've got to look at a quarter plus 3 times a 16th plus 9 times 64th and so on, or 4 times 16. Anyway, the point is it gets more complex. And having had that experience as a child, they've seen this. It's not unfamiliar. It's not this crazy thing. I don't know what it is. It's, oh yeah, I had fun with these tiles. And now I'm going to understand the mathematics of this fractal. For somebody who's already studied the mathematics of the fractal, they love finding these tiles because now they can see the thing they've been working with in an abstract way. So we're finding success in both arenas. I think it's too early to say which is better. We just want to have more opportunities to learn, more opportunities to get exposed to these ideas and to connect the concepts to the real things. So looking forward or reaching back, I think it's both valuable. And there are other there's a math community, mostly on Twitter, as I find it, that are all about making models and finding them, checking with us are ways that you can get going. If you don't have a math program or you're not doing any math, it's worth asking the question why and how to get started, because we need more people thinking about it and trying things for sure. Any other questions or?
Any other
Karen,
question from
turning
the
on your camera. It's nice to see the
participants?
participants. Yeah, I mean, I can keep going, but,
I have, well, if I can continue asking,
yeah,
so what age group are you targeting? Because some of the projects that you have shown, they require very basic math skills to understand, but there are others that they are a little bit more advanced. So are you focusing in, let's say, primary school? Here in Europe is a little bit different, but I'm talking from 6 to 12, more or less. Or are you targeting also older kids with this kind of tools?
so this one, we've sent a couple of hundred of these wooden frames to a community college teacher in Colorado. Most recently, I sent some to a teacher with a 3rd grade class who also posted pictures. She said this was amazing. The kids were so quiet, carefully concentrating, and then excited when they created something. The university teacher is connecting in a different way with this and getting the same kind of positive reaction. So I will not say that it's elementary school versus university level versus high school. We have made frames that you can stack balls in. And when we put those out for the public, we found, at least at one event, very popular with the 2-year-olds. They just want to put balls. And the math professors, when they get a chance to come in, they want to arrange the colors and see the patterns and put their hands on these things that they've been working with for so long, just in the abstract or in 2-dimensional on paper. So I just encourage you to try some math projects and see what happens. Being able to make something like this, well, maybe you do have a PhD student putting string in up and down and doing something very simple, but then getting very excited at what we built. So I would just really encourage you to try to get a math teacher in to find out what you can do in your makerspace. And contact us, mathhappens.org. We'll be happy to help and share and talk more.